Hello and welcome to the SkillStak Beginner Boost. This is the quick start for the SkillStak Beginner Boost 23. I'm going to show you how to get Linux as fast as possible and how to start experimenting with Linux and containers. We are not going to be doing a lot of hand-holding in this video. This video is designed to catch people up who are coming into the middle of the boost and saying, I want to keep up, but I can't. I don't know how to do all that. What is the minimum I have to do to keep up? Also, maybe you just stumbled across this video some other way and you want to play around with containers and Linux for the first time and you want to know the best way to do it, the fastest way to do it. And I truly believe that this is the fastest way to get started with Linux and containers on your computer. So that's very important. Let me just talk about that for 1 second. A lot of people will tell you to go to this and that cloud service or something like that, or SSH into this or connect to that to practice to using Linux. I personally believe that the best tools for learning things like Linux and containers are the actual tools themselves, not some simulation of the tool, not some broken, emulator. What you actually need to do is start getting experience with the actual tool, because like if you're going to be a doctor or something, you go to, or a surgeon, you're going to go and do surgery, and you've been doing it in a simulator the whole time, and the simulator is different than an actual person, and like all of a sudden blood is everywhere. No, the best way to learn something is to use the thing that you have to use, even if it takes you a little bit longer and even if it's a little bit more complex. But I have spent years, literally more than a decade, trying to come up with the absolute fastest way to get, anybody from 9 to 19 and older up and running on Linux, on their laptops, on their own computers, okay? So without a dependency on the internet. Let me tell you one other thing about this. I was teaching a group of 40 people at game development camp, and they had their internet was bad, so we were using an online service that I won't name, and I had to stop, and overnight I had to tell everybody to install an editor on their machine so that they could finish that game development camp, because they did not have dependable internet. This was a private school that didn't have dependable internet. So the reason that tools for development and for Linux have been made to run locally, I'm thinking primarily of Git. The reason that they've been made to run locally is because you don't know if you're going to have an internet connection. Okay, you cannot trust that you're always going to have network connectivity to do your development. Maybe lightning's going to knock your computer out, like mine yesterday or 2 days ago, or maybe you're going to be in the airport, you don't have Wi-Fi. There's a million reasons why you don't want to limit yourself to internet connectivity to do your development. Now, you still want to be able to phone home and, check in and get the latest or make your changes and share them with others and all that stuff when you do have internet, but you don't want to be dependent on it. So based on that, this is what I believe is the fastest way to get started with Linux on your computer. Okay. And we're surprisingly, if you're coming here to see how to install Linux on your laptop and get rid of Windows or Mac, this is not the place. That is, by the way, not the fastest way, right? That is actually counterintuitive, it's counterproductive, and I don't recommend it at all. Most Linux is actually used from the terminal in a server. There's a small, isolated, but very loud, noisy internet group of people who use Linux desktops on their desktop. We're not talking to those people, okay? We're talking to the people who want to use Linux for work, who want to use Linux for as an enabler. We want to use it primarily from the terminal. They're going to be using it from containers and Kubernetes and all that stuff. These are the people who actually make money with Linux, which don't necessarily depend on the desktop. Very few people, frankly, in the enterprise working world use Linux on the desktop, or we're even allowed to put Linux on the desktop. But a lot of us have to use Linux containers. So that's what we're going to do. Okay, so the first step here, and I know I'm sounding like a YouTuber more than usual today, but I have to go through this really quickly. Just had coffee and I got to get back to work. So the first thing to note here is that you're going to get terminal software. You need to install some terminal software. We are only talking about Mac and Windows. I just told you we're not doing Linux on the desktop, right? So you either have a Mac, and this goes for Intel or ARM or whatever you want, Mac Silicon, right? So you're going to go out, you're just go search for a thing called iTerm2, which we'll go do here from the internets. I have a whole bunch of things open here. So iTerm2, It is true that Macs come with. It is very true that Macs come with a terminal, but that terminal is not very good. It's super good. I mean, I've used it for years, but iTerm 2 is that much better, and you'll see how it's going to be better for you later. Has better integration with Tmux, which we're going to learn later. We're going to talk about this today, but just trust me, iTerm 2 is the go-to terminal for Mac, and so if you have a Mac, then the first thing you want to do is download and install iTerm 2. Okay. We're not going to go through how to do that, as I said, but that's what you're going to do. For Windows, the terminal you want is from the Windows Store. It is called the Windows Terminal Preview. And make sure you get the preview. The preview, I don't know if this is still true, but the Microsoft Windows Terminal Preview was accelerated. It was actually the faster of the bunch. You can go to the Microsoft Store and install it from there. But once again, make sure you get the preview. The preview has the newest, fastest things in there. The reason you need to get Windows Terminal Preview is because Windows doesn't come with a good terminal. And it, generally speaking, has faulty support for Unicode and UTF-8. And you're going to want that because everything that's written these days is written in Unicode and UTF-8. Those are the encodings that allow emotes, emojis, and all kinds of other stuff, Chinese characters, stuff like that. So you definitely don't want to use any terminal that doesn't have Unicode and UTF-8 support in 2023. So that's what this is for. Windows Terminal Preview is also integrated into, it allows you to use many different ways. Shell commands, which are is the name of the program that runs to support your command line. Okay, so step one, install a terminal. You need to go get, for a Mac, you need to get iTerm 2. For Windows, you need to get Terminal Preview. Once you get that installed, okay, you can start it up. Now, you can also customize it if you want. Both of them have theming ability. I'm not going to cover that here. If you want my theme, if you want my Groovebox theme that my particular color preferences, you can go look them up from my dot files. So that's on GitHub, github.com, rwxrob. I should probably go there. Okay, so github.com, rwxrob/dot. This is my own personal dot files. Not all of them are something that you would care to have, but if you do want to look up the customizations under install here, I've got, I'm pretty sure it's under here. Let me go check. There we go. So I have the Mac, I have the my iTerm 2 configuration if you want to use that. And then I also have the Windows one, Windows only stuff terminal. So here is the settings file for my theme on the settings there. So if you want to make your thing look exactly like mine, colors and everything, you can go, add my settings.json file as your starting file in the right place, and I'll let you research how to add those to. You need to learn how to do that anyway. So just if you want to customize it, go look for those two things, and you can go find my customizations under the dot on my rwxrob/dot/install, and then look for that. All right, so Bash. Bash is the name of the default Linux shell on Red Hat and Ubuntu Linux, which are the most significant Linux distributions in the world for use in enterprise. There are lots of other Linux distributions, and you can go to other channels and fight about why they're better than others. There's no debating that Red Hat, Ubuntu, and then to a lesser extent, Alpine and BusyBox are the only Linux distributions that matter for enterprise Linux, cloud native development and computing. There's our dog. So make sure you go and install Bash. Now, this is a little bit trickier on Windows. Well, actually, Windows is not too tricky, but let's do Mac first. So for Mac, you're going to need something called brew, and Mac brew, the missing package manager for Mac, it's called. So this is actually a Ruby program, and this is one of the very, very few times when I'm going to tell you that it's okay to just run something from the command line by copy and pasting it. Okay, so you can see that it says bin bash, and that's because I'm pretty sure it already comes with even the newer Macs come with Bash. They come with an older version of Bash. If they don't, but you still need to update it, right? It might be that you have to, instead of doing bin bash there, you might have to do something different, but I'm pretty sure that actually will work. Anyway, you need to get brew installed. Okay. Brew is the way you're going to be installing things on your Mac. Macs are actually, under the hood, they're actually BSD Unix already, which is really fantastic. It's one of the reasons Mac people have been using Macs for years for developers, because it has a very, very strong command line game from the get-go, right? I'm hesitating on the whole bash and thing because Macs about 2 years ago, they switched over the default shell from bash to Z shell. We're not going to fight about shells right now. I just told you why we're learning bash. You want to use Z shell, fine, for your interactive shell, but you have to learn bash anyway because it is the primary shell language for all development of containers and everything else. It dwarfs everything else. So that's the shell that we're going to learn as a shell scripting language in the SkillStack Boost that we're going to learn, etc. So go ahead and install brew. And once you have brew installed, it's pretty easy to install bash. In fact, it's pretty easy to install anything. Just do brew install bash, and that'll come down, and that will update the version of bash you have. Next time you start up a terminal, you'll be able to do that. It's kind of implied here, by the way, that you'll be running your terminal in order to get a command line in order to do these steps, at least that one for Mac, right? Now on Windows, you don't pull up a terminal, right? And in Windows, you're going to install something. I'm going to get crap for this, but I'm going to tell you briefly why. Just do it, okay? So in Windows, you want to go to something called git. If you just do a search for git-bash or git-scm, you'll find the git-scm.com website. This is the standard Git distribution for Windows. What's Git? Okay, Git is, the name behind GitHub. Git is the premier tool. It's probably the most famous thing Linus Torvalds made, who besides Linux, he made Linux. And then the second major thing that he made was Git. Git is used to manage source code and knowledge bases and a bunch of other things. It's going to be the basis of everything we do in terms of synchronizing our content. So we're going to learn Git, but more importantly, we're going to install git-scm or git-bash onto Windows. And so you click on download for Windows, you get an MSI, package thing. You can click on it and run it and just go through the install and it'll do the right thing. Okay. As soon as you do that, then you can actually test it out by opening up Windows Preview, which is what I'm running here. You can open up Windows Preview and let me see. Where's my thing? Here we go. Wait, what? Wait, here we go. All right, so you need to open up Windows Preview. Where's my thing? It's not happening. Okay, there we go. So when you have, this is my Windows Terminal. When you have Windows Terminal open up, you can click on the plus here, and it will open up a new terminal for you, right? So, or you can click on it, the little down, what is this, down tilde, I guess. And you can look and see, there's a lot of other things from WSL2. You can get a traditional old school prompt. You can get a PowerShell. Those are fine if you need those for Windows, but the one we're trying to use is git-bash, and you can make that your default by changing up your settings, which is also the place you go to change your theme. Okay, so play around with that for a bit, but make sure that you get it so that when you click on the plus, you get a new shell. Now, your shell, well, we'll talk about prompts and what they are, but this looks like Linux, right? It's not. Okay. It's important you understand this is not Linux. This is Windows. And the main reason that we are doing git-bash instead of anything else, yes, instead of WSL2 or any of those, is because git-bash is Windows. Let me say it again. Git-bash is Windows, right? All of the other options are Linux. Git-bash is bash on Windows. And let me prove it to you. So, some people say it's old, nobody uses it anymore. I say, bah humbug. We all use it a lot, actually. And because what it does is it allows you to do commands like find and a bunch of other fantastic things that are generally associated with Linux on Windows without messing up the permissions, which WSL2 does. I mean, I'm not going to go into it. If you want to hear me why I hate it, see how these all have exe at the end? This freaks people out that know Linux the first time because they're like, oh my God, that's like, it's almost like if I had bash on my Windows machine, because that's what it is. Okay. It's what it is. And that's why you want it. Sometimes you want to be able to deal with your Windows, files and stuff from the command line using your favorite shell bash. And if you know, bash is also compatible with POSIX shell and some of the other shells, Z shell. So here you go. You can see that these things. So that's the primary justification for using git-bash. It'll give you the git-bash can get a little bit interesting when you're using command line options, because those options are interpreted by Windows. And they don't always look the same. I don't know if you saw that, but here we have C users rub, right? Instead of saying C colon whatever / users rub. So you have to make an adjustment there. We're not going to talk about that adjustment right now. Just git bash, okay? And then you can say that you actually have bash on your Windows machine. Now that's not enough though, because that's not Linux. It's bash, but it's not Linux, right? So it's bash on Windows. And over here, when you install bash over here, you actually have bash, but now you have bash on BSD Unix, or otherwise known as Darwin, which is what's running on Mac. So we still don't have Linux. We have to get Linux, right? With true Linux in order for us to learn it. So this is where we do the third thing. And then we get another thing. We go to Podman Desktop, okay? Podman Desktop, which is the place to go. I had a problem with DNS. Okay, so Podman Desktop, what is this? Okay, Podman Desktop is Linux in a nutshell, okay? It is a version of Linux that's running in an emulator on Windows. Long story short, modern LXC containers, that means that when you hear about cloud and containers and Kubernetes and all that stuff, you're implicitly talking about Linux containers. Somebody pedantic person is going to say that BSD has containers. You don't care. When you hear the word containers in 2023, they are talking about specifically LXC Linux containers, right? I'm going to say something else that's going to blow people away. You cannot have a container, a Linux container, without Linux. Well, Mr. Rob, if we're talking about Windows and Mac, we don't have Linux. How are we going to use containers to run Linux without having Linux? Now, this is where things get a little bit weird, all right? So when you download and install Podman Desktop will install, and you're like, well, why not Docker Desktop? We'll talk about that in a sec. When you download and install Podman Desktop, you install a Windows application that emulates Linux, and it'll prompt you to install WSL2, so it'll be faster. WSL2 is Windows Linux kernel that runs inside of Linux. You can imagine having a Windows machine and then have it also run Linux as a program inside of it. It's not particularly like that. It's kind of like next to it. But anyway, so WSL2 is Linux. All you need to know is you click on download now, you install Podman Desktop. When it asks you, do you want WSL support? You say yes. Do you want me to install WSL? You say yes. You accept all of those defaults. You probably have to reboot someplace in there. And at the end of the day, you'll have a thing called Podman Desktop that you can use to fire up Podman, right? Now, we are not, for the boost, we are not going to use the fancy GUI that they have created. We're not going to use that. I'll show you it a little bit. But for the most part, the reason we're doing this is because we want Podman on the command line. Okay, and we're going to, that's why we installed git-bash. So we're going to use Podman from the command line as will benefit you on the job, as opposed to being dependent on some random GUI that may or may not be working or broken or anything. And people have reported, both with Podman Desktop and Docker Desktop, that the GUI stuff doesn't necessarily work, but it can give you an absolute beginner a sense of what's going on, what a container is, where it lives, and all of that stuff. So download Podman Desktop, install it, you select the option for WSL2, and go ahead and start playing around with it, right? Then after you have that installed, the last thing we're going to put, and that goes for Mac, by the way, the reason we did Podman Desktop is because Podman Desktop supports Windows, it supports Mac, it supports Mac Intel chips, it supports Mac with Apple Silicon, it supports everything. And the way it does that is something called Kimu, which is an emulator that's come from long pedigree of Linux, and it's exactly the same way that Docker Desktop does it, and it's building on top of that technology. When you are done installing Podman Desktop, you will actually have a container engine. In other words, a container machine, I guess. A container engine running inside of a virtual machine. And that virtual machine is Linux. Now it's very tiny, so you already have your own Linux machine. And you might be wondering, well, why don't we just use that one? Well, that virtual machine of Linux has been really sized down, and it only has one purpose. Its purpose is to allow you to run containers, otherwise previously known as Docker containers. We're not going to use Docker. We're not going to talk about Docker. We will occasionally pull down a Docker Hub image, but for the most part, the company that is largely credited for inventing the container craze, even though they didn't invent containers, they were invented by the Linux community, is now largely irrelevant. And I don't want to go into it. You can go do a search for why does Docker suck? And you'll see all of the reasons that nobody on the planet wants to use Docker anymore. Okay. And so we are using Podman Desktop, which comes from the Red Hat company, which has got very popular adoption within the enterprise. There, we could debate all day about the ethics of Red Hat and all that. And I mean, I've had Red Hat stock since 2002 or something. I think I sold in 2008, which was stupid. But so get Podman Desktop, get it to work, and then go to your command line. And this is the next step. So once you have Podman Desktop, we need to start seeing if it actually works, right? So once you get there, you can go start up your Linux terminal. We'll use a clear command. We're going to learn all these commands over the course of the boost. So again, this is git-bash on Windows. Now you might be on iTerm 2 and you might have your terminal loaded, but get to the terminal and then just see if Podman's there. Podman -- help. And you can see, and I'm good. This is one of the few times I'm going to do this, but I'm going to scroll with my mouse through the terminal stuff. You haven't learned about pagers and stuff yet, so that's okay. If you know them, go ahead. But manage pods, containers, and images. So in a nutshell, an image is kind of like in our particular, an image is kind of like an application with all the files and stuff that it needs, frozen into a container, into an image that can be shared with other people. And when you run an image, it makes a container, which is a single instance of that image. And then that container, you could actually make another one and another one and another one. You can have a whole bunch of containers all coming from the same image, almost like, that really horrible scene from Quantumania where, Scott gets turned into all his alternate selves, kind of. You can think of it that way. So an image is, and in this case, the image is, we're going to use an image that's not just focused on a single application, but that's focused on pretty much everything you would want to emulate a Linux desktop distribution. Okay, so some of the larger images in the world they actually contain more or less miniature Linux machines. Now, they are not Linux machines. Very important. That word does not apply here, right? And the thing to know about containers is that all of the containers use the same Linux kernel, but they're protected from one another in special ways that we won't get into. Okay, so when you create an image or you use like Ubuntu Linux image like we're going to do, you're creating containers, and all of those containers, they have separate files, they have separate running processes, but they're all using the same kernel on the same host system. They're sharing a kernel. That is the fundamental difference between an image in a container and a virtual machine. When you have a virtual machine, which we'll hear about, virtual machines actually create different instances of the whole kernel and the machine. So you could have 5 different versions of Linux and run those under a virtual machine. In previous boosts, we actually had to install a virtual machine because it's, they're heavier, obviously. They are separate machines, so you can do things that you can't do on containers, but this year and going forward, we're going to do containers because the goal is to just learn Linux, learn the terminal, learn how to use how to edit files, learn how to write bash commands, and all of that can be done with the container, which is lighter weight, smaller. It's also fundamental learning, and if you ever want to get into cloud or you want to get into Kubernetes or any of that stuff, all of that stuff depends on containers. So you have to learn it, right? Do you have to learn how to make a Docker file or a container file? Not necessarily right now, but you definitely need to know how to download an image, pull an image, they call it, and use a container. And I have made a container for you, an image for you, so that you can get started right away. And I'm going to show you how to use that. Okay. So notice how this says podman.exe on my computer. That's because Podman is actually, in this case, it is an executable that's been compiled to run on Windows. Now, it doesn't look like it because of git-bash once again, but it's actually running under Windows. All right, and you can read through all the commands and see. I'm just going to tell you the essential commands you need to do to get started. the first command is podman machine start. Okay. You might have to do podman machine init up front. And that's going to, that virtual machine we talked about, that's going to start it up, right? You can probably see that there's a Podman machine list if you want. This will show you all the machines. There is WSL, Windows Subsystem for Linux. That's what it uses. That's why I installed it on Windows. On a Mac, you don't see that. You'll see something, but it won't be that. It'll be QEMU or a KVM or something like that. But that just shows you that you have a machine. If you forget that you have a machine, that you can do Podman machine list to see this. This is not something that Docker Desktop has, so I'm going to show you that. It's very common to forget to start up your machine and to try to do all the normal, Podman Docker commands to go get an image and stuff. So make sure of that. And then to start the machine, if it's not there, you do Podman machine init, which I'm not going to do. You just do that because you don't have a machine. And then the next step is going to be Podman machine start, and that will start up your machine. So now it'll handle requests to pull images and to run them and stuff like that, which we're going to do next. Okay, so back to our steps. Where are we? We installed the software. We're installed. We got Podman all installed. We can see that it's running from our command line. We're not going to use the GUI. We're going to use the Podman command. And Windows is podman.exe, but we're not using the exe. And then Mac is Podman, okay? And then we're going to pull and run a container from the desktop SkillStak workspace image. Now, there's a lot in that step, but what you fundamentally need to know is all it's going to do is it's going to go out to, here we go. So we're going to go out to github.com, rbxrob, and I don't have a repo for it that goes with it yet. So you just go over here and click on packages, and I'll put this in the notes, and there it is, ws-skillstak. The WS stands for workspace. And you can click on this and you can see that it tells you the command to use. Now it's using Docker. Just as a note of clarification, as I said, Docker has been the go-to tool for all of this for more than 2 decades. So about a decade, I'll say. So anywhere you see Docker, you can put Podman now. Okay, Podman is what we're going to use instead of Docker. Some people even alias it to it. I wouldn't do that. I would actually use the Podman command. And this tells you how to get this image and run it. So GHCR is the name of the GitHub container registry. That is where we are storing this. Then we have the name of my account, and then we have the name of the image that we're going to pull, right? And the image has all the stuff necessary to do the boost. And then which version, and latest is the default. If you leave this off, that's fine, but you can always add that. And that is the latest version of the image. If I push more than one, you could actually go get the previous one if you want to. And that won't pull down the entire thing, right? Okay, you can actually do this in 2 steps if you want. You can actually just use the run command, but let's go ahead and do the pull command. So you can get back to your command prompt, and you can do podman pull and then a ghcr.io/rbxrob/workspace-skillstak. Okay, and this is going to pull down a container with all the stuff for the boost. So it'll pull it down. Mine worked really fast because it's already there. Okay, it's already there. And the way you can see if it's there is you can do Podman images, and you can see all of your images. And among the many images I have, here is the ws-skillstak. I have a local copy that I used, and then I have the one that I got from the remote location. Okay, so you'll probably just have the one. All right, now we can actually run that for the first time and do something with it. Okay, and I think actually, let me check something. Podman ps-a. I think I already have one called Workspace. Yeah, I do. So I'm going to actually go ahead and delete that. Or actually, no, let's just go ahead and do it. So now you've got your git-bash. Now we're going to run our Linux containers. So you do podman run, right? Dash it, run it. Just remember, run it. The I stands for interactive. The T stands for TTY or terminal, so that you get an interactive thing you can relate to. If you want to not use it after this, you could do /rm, but we're going to keep it around because we're going to restart it and attach it frequently throughout the boost, right? We want to keep it around. And that's not always true with containers, but in our case, we're going to do that. So run it, and then well, what are we going to run? Well, we're going to run And you could just probably, I don't know if it was, you could probably just try to do ws /skilstak. Right, you should be able to pull that off now because it's local. You now got a copy of it local. If that doesn't work for you, you can go ahead and type in and I'm using the arrow keys here, the GHCR or whatever, right? Okay, so there are a couple of other things to put in here, just for fun, and to make it clean. So one of them is host name. We're going to give it a host name. If you want, you can give it a host name called /skilstak. That will become this TV thing here. Yours will become, that's what that does. Okay. And then we want to give it a consistent name instead of a random name. We don't want it to, this is the name of the container itself that's going to create from the image. We want that name to be unique. So any unique name, okay, you can call it whatever you want. I frequently call mine WS or workspace. You could call it, you could call it boost, but you're going to be typing it a lot. So let's see if boost is not taken. I don't know if it is or not. We'll try it. So once again, we have the Podman command. We have the run main action, which will run that container, which has already been pulled. And by the way, if you haven't pulled it, it will pull it at that time. And then we're going to give it a host name /skilstak just so that we don't get some random number here. Instead, we want to have that be nice and pretty. And then we have the name boost, which is the way we'll refer to the container to reattach to it later on when we exit, after we exit. And then we have the name of the local, now local image that we pulled down. This image could be the long name if you want to. Thankfully, you don't have to do this all the time, but you can. There is actually one last thing that is going to help you, okay? And that is mounting a volume, okay? So if I'm going to go ahead and tell you to do this, even if you might not want to do it. So you do -V, and what this is going to do is it's going to share a directory folder between the two systems. All right, so we're going to create a folder called shared and : and we want that to mount into, and this is Windows. Windows or Mac can use 2 slashes, but Windows has to have 2 slashes. And we have shared, and we want it to be shared, to be also mounted into shared, so that we have a shared folder in both systems. If you, well, that's good. That should be enough. There are other things you can put. Now, that's a lot to memorize. That's why I'm making this video, right? And you're going to understand what all of those things mean by the end of the boost. But this is your way to run a command. You could try to do the same thing by clicking on a bunch of little pretty pictures, but this is good for you to know. So once again, Podman run it, interactive TTY, hostname /skilstak, container name boost with a mounted volume. Shared directory is mounted to /shared in the program, in the running container. And then we'll have this ws-skilstak as the image. Let's try that and see if it works. Live demo. Error created container boost is already in use. Okay. Let me actually go ahead and remove that then. So if you don't know this yet, but pretend you do. So we're going to delete. Be careful doing this. Don't do this on accident, because you'll lose all your progress. All right. So, but I'm going to go ahead and remove one get it out of the way there. And now I'm going to go run. I'm pushing the up arrows to go back, and I'm going to run this command. Now this should run. It uses, okay, so that you see how it just ran right away. And you only have to do that command once for the boost. If you do it again, as we just tried, if you exit out, it'll get you out, right? If you do it again, you'll get the error I just got, right? Well, don't delete it. You want to use it, okay? So how do you attach to a running, so let's go see Podman ps-a. That'll show you all of your stuff, and you can see down here is the one you can see by when it was exited and how long ago we got it. This is the container that was made from the localhost ws-skilstak. That made my localhost one. Yours might be ghcr.io/rwxrob. Either way is fine. Okay, and here's the name. So if we clear the screen again, let's actually reattach to that same container, okay? And we're going to learn lots of different ways of doing this, but the fastest is this: Podman start -a boost. All right, so what that does is it takes the stopped container image that we created with the run command, and it runs it, and then we attach to it. And so now it just started up, and it's just exactly where we left off. Our commands are here. Fishies is here. Sunrise is here. Neo is here. You know, I mean, all these fun, useless things are there. The SL train is here. So now you've got Linux. You've got it. You've got a full-blown container of Linux. And for our purposes, for educational purposes, it's very nice to do this. This actually do things as root too. If you want to get root, you know, you can go su dash. And the password is password, password. It's just a container, so that's fine. Oh no, we're root now, right? You can actually do things to your boost container and destroy it, and it's fine because you could always go make a new one, right? But you still have to, don't do that, but eventually you can do that, right? So you could start up another different container from the same image if you wanted to get really creative and see what happens when you try to destroy your own container. But you know, so that's why we're doing this, because you're nice and safe. You're isolated. The whole point of containers is to keep you protected from the rest of the host operating system. And in this case, that would be, you know, a WSL Linux virtual machine running on Windows. So none of those things are going to be affected by what you do here, including, you know, excessive memory utilization or any of that. That's why containers exist. Okay, so this has been a really quick introduction to how to do this. As you can see, the default user is user, but I mean, you can do anything. You can change your password if you want to. Password, I'll put it to new password, something else. And it's like, uh-oh, you have to have a longer password. Okay, but, you know, Control C, all those other great things. Oh, I don't want a new password. Come on, get me out of here. But all right, I mean, you can do whatever you want. Just remember, if you forget your password, you can't get around it. Okay, I mean, you can't get around it. You can't get around it. So if you change your password and you forget, you'll be locked out of your own boost container. All right, this has been a fast video. Hopefully, that's been enough to get you started. But as you can see, then every day that we go through to do the boost, you know, we're going to be doing bash development. We're going to be doing VI. We're going to be doing tmux. We're going to be learning how to search from the command line with links. All of that stuff is prepared and ready to go for you already. Those of you who have started from the beginning of Boost have built up your own container, but it's actually probably good for you to have two containers. One of them that you're using to build up everything, and one of them that's had everything already finished. It's kind of like the answer at the back of the book, right? And you can actually start up a different container if you want to, right? So, and the people in the Boost have done this, and I'm just going to end with this. So you can actually start up an Ubuntu container straight off of the internet that has nothing on it except for Ubuntu, right? But that doesn't look like the container that I want. There's so many things I have to do to it, right? Well, the Boost actually takes you through all the steps to take a raw, you know, modern Linux Ubuntu 22.04 LTS, you know, container and convert that and build it up into a workspace container. And the process of building a workspace container is enough to help you learn everything that you really care to know about the terminal and, frankly, containers as a user and as a beginning developer, as a beginning system administrator, as a beginning hacker, all of those things. So that is what the Boost is for, so to get you started, and you're ready to go. So you can fire up this one. If you wanted to test Kali Linux, you could do it. But if you want to go reattach, you can actually run another ws-skilstak container if you want to, and you could actually have 2 or 3 or 5 or 10, but just don't forget which one you're using. But to get back into it again, once again, is a ws-skilstak, and then you want to do the name of the container, not the image. So now we're back into our other thing, and we can get going for the rest of the Boost. I hope that this is what you needed. I'm reading from the comments really quickly. It's been an hour-long video, and my normal trolls are giving me a hard time. And that's all. Bye.